Wait a little bit. Looks like something is moving. Go here, go slides. Okay, so we can do this as in the example, right? So we have 1, 2, 3 different ways here of assigning values into variables. Just checking. So there seems to be maybe working, maybe not. Where am I? Here. So note we have the general form of variable stores the information given in expression. Right, and it's here not value, it's expression, because if I have a value, right, 2, that's just a number, but I also can have 2 by 2, which is an expression. I can have a string, which is an expression. By the way, sorry, I go over here. I can even have, let's go like this, 2 plus 2. Right, that's an expression being evaluated. Here the addition. I can have string plus string. I can add up strings. It's called concatenating, and so putting them together. And in Python, it's super simple. If you have other programming languages, it's a little bit more tedious. Check again. So this is up now. Very good. Right, and then whatever expression we have on the right, we can store on the left with the equal sign. Okay. Working with variables. So now we take the information stored in a variable and we do some operations on them. The operation can be anything that may or may not change the content or the information itself. So we can add up things, we can subtract things, we can multiply, we can remove characters, we can remove strings, we can check the content of a variable. And the arithmetic operations we introduced already is plus, minus, multiplication, multiply, divide, and modulo. So the remainder operation last. Okay. So let's see, we have here some examples. Example modulo. Which modulo it should be? Copy paste the code. So when you have the slides, you can just copy paste often code and see what it does. Right? And here the remainder for the division of 3 is given as 0, 1, 2, 0, 1, 2. If we divide an integer by 3 starting from 0 to 4. So far, so good? So the attentive person will have noticed that I have here 4 print commands, right? 4, 5. Why do I have print commands here? Let's check. I can just take that source code, source code, and delete everything except the modulo, the remainder operation. Okay, so we can give you what's going to happen already with 2. So when I have 2 different commands in one line, in one code block, Python will give me as iJupyter Notebook, I should say, will give me as output only the last command. So I check this again when I add more commands. Right, I only get 2 remainder 3, right, which is here 2. I think this battery is off. Next one. So we continue here, and So funny thing in this room, the batteries are always low from the microphones. Yes, they're both off. I don't know, we made like charging microphones would be, I don't know. Yeah. Let's check. Okay, so that means I will shout a little bit louder for a bit. Where are we? So we are just having here the last line always given out. If I want to have more information, right, in my output, right? So I have here the inbox and the outbox. I can put a print command around it. Then I had the output, which is still only the last command, right? But the stream of data is printed as well, right? So I print here, I print, okay, 0, remainder 3, that is 0. I can add more commands, and it will show me the results in between. It will not give you access to the information. It just streams it to the screen. Okay, this is a very, very important difference. Print is for you to follow your program or to give the user some information, what's happening in between. It's not for Python to use the information. So what do I mean with that? Let's define a function. Do you remember defining a function? So def adding numbers, for example, a and b, and then we said return a plus b, right? Now when I call adding numbers 2 and 2, 4 and 4, I get 8. So far so good. Now that is an expression, right? I can say store the value of the expression in C. Now C contains the value 8, right? Now I'm changing. Now I copy, adding numbers, and instead of return, which is one of the important internal keywords of Python, keywords let's say, I changed to print. Print is a built-in function. Adding numbers version 2, let's say. Execute that function. I can also call this function. Let's say 8 and 8. I see the right result. I see 16, right? But the difference is now when I want to use the expression and store the given or the evaluated information. If I now say D equal print result and I ask what is in D, I don't get anything. Because printing puts the information on the screen. But return directs the information flow back to Python, if you want to say it like this. That means I can use this variable again, or the expression result. Right, so with return, I return the information and I can further use it. With print, that is only for the computer screen, for the user to read. If I don't return it, the information is not accessible. So to make it accessible, I just return A plus B, okay? So when I add return in my adding numbers version 2, I can now access the information in D. Okay, back to the actual topic. So we have here modulo, we have right. So we just use the function. The function is called print, but print is only for the, let's say, for the user to display information. Now, if you look carefully, print, right? Again, green font. That means it comes with Python. Python knows what it is. I don't need to define it. Then I want to learn more about print. I have two options. I can use the question mark, which is a magic symbol. I execute, and I get a lot of information. Signature of the function. That's the function head, right? I provided some arguments, a separator, and an end. Doc string prints the values to a stream. The stream is your monitor, right? This is where the information is streamed to your eye. In principle, you also can stream to a file or do something else. That is file input output. Separator is how you separate the string, and is how you determine the stream. Let's play around with this a little bit. Print my string. So far, so good. First argument. Second string. So far, so good. I can have a number. No, sorry, just a number 100. Okay, so we can print many objects, many variables, many data containing objects. Now let's check the magic command again. So all of this, right? So 1, 2, 3 objects are in arguments. Now the separator, right? Sep string inserted between values default is space. And so this one here tells you the white space. So separator equal white space. It's an optional argument. So we have access to actually change it. What do you want to change it to? How about 3 dots? So now we don't have a white space anymore. Every time an expression is completed to print and Python starts printing the next expression, it will put in the separator here. Okay? So if I change this to dot colon dot, it changes that. I can put it in numbers. So 10, not strings, 10, 50, and I can separate them by a colon. What time is it? 10:29, right? Beautiful. So I can simply do some minute, hour, and have a format like in a digital clock. Hour is 10, minute is now it is maybe 30, and then I print hour, minute, so far so good. If you don't specify the separator, by default it's a white space. It makes quite a difference, right? So far so good. I see a lot of hacking the keyboard. Play around with it a little bit. Okay, so we also can enter print into the help function, which basically gives you the same information as the magic symbol. Sometimes, however, the magic symbol doesn't work. In some other development environments, integrated development IDEs, so then you would just use help. Do you remember our beautiful function adding numbers? Sorry, adding numbers, yeah. Oh, not add numbers, adding numbers. Oh, that's not very helpful, isn't it? Oh, thank you. So why has our function no help? Because we never specify it. So we go to our function definition over here. We press double quotation 1, 2, 3 times. So we have 1, 2, 3 double quotation. And then we can add some text. Here we want to add 2 numbers. Execute. Now Python has updated information for this function. We go to our help function. Oh, and we get the text here, right? Here we want to add 2 numbers. So when you want to provide information to your function, you have to do it yourself. But it gives you the possibility to provide some form of documentation. It also should work with a magic symbol, right? Here. Adding numbers, this is my signature, the head of the file, and the doc string, yeah, the one with the 3 double quotations. Here we want to add 2 numbers. If we are more specific, right, we even can define our variables A and B. Go up again, go here. A first number, B second number, try it out. Beautiful. So you all can now write very elaborate documentations for your functions. Okay, let's see what else do we have. Right. So how do we normally use the print function? So back to the actual topic. We want to follow what the code is doing, right? We want to provide some ongoing information for some big calculations, right? If you have to wait 24 hours, it might be, if you want to wait 24 hours for like a big calculation, be like, does the calculation work or get it stuck somewhere? So we can provide information like every 5 minutes, hey, my calculation is working, I'm done 5% on the way, I'm done 10% on the way. And it's a great way to tracking errors. It's not the only way, right? There's something called debugging, but debugging we will not go into detail, and for this course it's basically overkill. So if you have an error, right, and you want to check your program flow, print out at several stages or different stages of your program execution, may be able, and might give you access to follow or find the error. So, okay. Right, so here's one task we actually can maybe skip. There is, let's copy here, just show you the right way. So that was meant as markdown. Next lesson. So remember the markdown from last time? We had like this human readable information to our Jupyter notebook. I have here now text followed by some weird bracket code like pointy bracket open BR for break line and then not. So what does it do? Well, let's do it like this. If we have text in our markup and we don't use BR on break line, so we would have it in one line. So here print and true, and without the break line, it looks like one big string, right? Not very neat. We can also have it as a list, also works. So now, what happens when you write down in Python in a code block, not in a markdown, these words here? Print true, 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 def, if, import, and, or. What's happening? What do you observe? So when I write like import, or suddenly it's green, right? When I write if, or suddenly it's green. When I write print, sorry, suddenly it's slightly different. Do you see the difference? Here's like fat font, bold, right? And here's just like normal font. How about true, true, true? Right, so there are different levels of text highlighting. Normally bold, green font, or in Jupyter at least it's green, can be another color. But bold here means it's a built-in keyword. So Python know what it is. For example, else equal 5. We want to assign a value to a variable. The variable is named else. But Python occupies this word already, right? Python knows, hey, else, it's what I need. So Python does not allow this operation because Python needs certain keywords to function. These keywords are protected besides your variable naming rights. So you cannot override a keyword because it would be silly, right? It would lead to actually quite silly mistakes. However, do you remember print? Print is a function, it's not a keyword. But there is something that we actually can override. We can override this. Do you see this? Because print is a built-in function, it's not a keyword. Function we recognize because we need to use the round brackets and give it an argument. I actually don't need to, it's an option. But it's not protected. So we can override it. But then I can't print anymore, right? A little bit silly. Let's see. So to restore the standard, right? If I did a silly mistake like this, which I didn't want, I just restart my Python kernel, right? It sets back everything, and I should be able to print again. Just don't do the silly mistake again. Okay, so here in this task, you should see if a keyword or a text turns green, it's either a keyword or built-in function. Don't mess up your built-in function, you might need them. And your built-in keywords you cannot override. So your variable names must be different than that. Okay. Oh, last one, right? Almost always forget. Keywords are case sensitive. So 2, 2, 2 are all different, and only one of them is a built-in keyword. This one. This one you cannot override. The others can. Okay, task 5. Define, yeah. So typo here, define the variables and perform the operations. So this one we can just copy paste. New line, copy paste. Now define my variables, objects. A, B, S1, S2, S3, S for string, and then cats eat mice. Okay, very good. A plus B, that's the task. A plus B, easy. No problem. S1 plus S2 plus S3, okay. S1 plus S2 plus S3. We already met string concatenation. So we can put 3 strings together with a addition sign and get one big string, right? String start, string end. Okay, easy. A plus S1. So an integer plus a string. So what is an integer plus a string? Integer plus integer is an integer, right? Because integer are complete sets, right? And every element of a set and the combination of elements in a set gives you another element of that set. But now we are starting to mix, and then we must wonder, what kind of space would a number and a string match together? And the thing is, they don't. Right? We cannot add up strings and numbers because they're different types of information. So what we can do instead is to convert an integer to a string or a string to an integer. That we can do. Okay, so the error message anyhow is unsupported operand type for plus. So the operand is addition plus. So we put things together. In Python, it's more than just addition. Right? You put things together. There are numbers, we add them up. We cannot, right? So unsupported operand type for integer and string. So we either change, remember what is A, right? And the type is what? Well, it's int. We could change A to a string, right? So we use a conversion function, str, string, pass it an integer, and we get a string out, right? So the type now is string. And the difference is that our 1 has these little quotations, but that is not a number, it's a string representing a number, okay? Different. But if it is string, I can add another string, no problem. Let's see, what else can we do? Can we actually convert integer? No, cannot. There is a way, however, to use the Unicode character to convert character back into a string. Anyhow, we do this for an exercise. So go back to the task. So the task is actually, what do you observe, right? What is the takeaway message here? The takeaway message is we can add up integers, we can add up strings, but we cannot add up mixed information. And we need to convert them to the same building block of information, here strings, and then we can put them together. Okay, next task. The fix my code sections. Here in bold font, I give you some error message, some code that is not working, and you have to fix it. Why do we do this? Because when you start programming yourself, it is more normal that you do mistakes than that everything is working at first try. So we were facing a lot of errors, and we must be able to link the error message to your source code, finding the error and fixing it. And so fixing code is a good exercise. So here, this one we do together. I give you an error message. Print A plus B, right? Print S1 plus S2 plus S3. Print A S1 plus S2, and it will tell you S1 is not defined. Want to try? Copy. Reproducing errors, right? So when you give me code that is not working, first thing I normally do is I try to reproduce the error. Because it could be your machine that is faulty, not your code. S1 is not defined, yes. I reproduce the code error. Now how do I fix it? What's wrong? Well, at close inspection, you will see that here S1 has a small s, but in this line, I changed the small s to a capital S. Oh, that doesn't work. So I found a possible mistake, I change it, I execute, and still doesn't work, but pay attention. The, well, not literally, but here the code error, right? The error message has changed. It's now name S2 is not defined. So I'm like, yeah, S2 also has a capital S. Let's change this. Yes. Now I fixed my code. So the information Python gives you concerning your errors are helpful. They point you in the same direction. You just need to be able to understand what this meant and know how you fix it. Okay, it's a skill, you need to practice it. Okay. Right, so we concatenated strings. Sometimes, because of EMI, I will put in some information on English words that I think may not be on the B2 level, or at least not common. But remember, this university English, in principle, you should have English B2. Okay, but if you don't understand something, you're still welcome to ask. Everything else, what I think might be uncommon, I put in my slides where I can. Here, concatenate. There are some Chinese characters somewhere. Putting things together as connected series, is this correct? I can't fix the Chinese, right? So this is beyond what I can do. But I can copy paste from the internet. Oxford Dictionary, I think. Cambridge University Press. Okay, so you know what's concatenate. Iterate is another one which we are going to use commonly, and that is doing something again and again, usually to improve something. Right? We iterate over your code to fix the errors. We iterate over your thesis to make it readable. In Python or programming, we iterate over an iterator. That's the object. The other one is the a verb to repeat something. An example, here I have x equal 1, and then I say x equal 1, so x, let me try again, x equals 0 in one line, and the next line I say x plus 1, that's my expression. So when Python evaluates that part, it becomes 1. And then I store the information in x. So at that point, x will be 1. Okay, I repeat this. I iterate the same command over and over again, 3 times. So when we reach this point, which value will be in x? Well, here x is 1. Then we have 1 plus 1, so x. So x is 2. Then 2 plus 1 is 3, stored in x. And then 3 plus 1 is 4, x is 4. So which value is x? Well, 4, right? So far, so good? Yes, no, maybe? Yes, okay. How about this one? Why don't you try to copy the code and then tell me which value y has? So what do you get? I get -1. Did you get that too? How does it work? Well, previously we said y equals, or x, right? Y plus 1. And it's very repetitive. So execute y becomes 0. We also can say y plus equal 1, which is the shorthand notation of y plus 1. So plus equal takes the value and increases it by 1 unit. So we can ask what is y. So we go from 0 to 1. We can even do y times equal 10. So we take the value stored in y multiplied by 10. So now y is 10. We can execute it again. Then y should be 100. Yeah, we do it again. 1000. We can check if we can do divide, or we can even do divide. Can we do subtract? We can do subtract. Can we do modulo? We even can do modulo. Fantastic. Okay. That is fun, right? So shorthand notations are one thing. What else? Okay, questions, right? So we have tasks, we have fixed my code, and we have questions. So which type of number is stored in object k? So you're given k equal 1. What type is k now? Okay. So you can always like take the code, copy, paste it, right? And then to ask the code what type it is, we just have type k. Oh, it's an integer. That's my data type, right? The type. Okay. So when we have the shorthand multiplication by the factor of 10, what type is k? where the value will be 10, but what type do you get? We do the same thing again. You copy, paste, you get a result, doesn't print, okay, but we ask what is the type? Int, okay, integer. We do the same thing again, right? We iterate, we do the same thing over and over again. So over here, we execute. What type is k? Still an integer, right? Okay. And then we divide, well, the value here should be 100, and we divide by 9. What type is k? It's a float number suddenly, right? So Python does type conversion for you. Python is like, you have 100, you want to divide by 9, I can do it. But I'm going to change your data type from integer to floats because otherwise it doesn't work. My other programming languages, C, Fortran, they always tell me, oh, you try to do a type conversion. I stop here because you don't know what you're doing. Python is not so picky. Python will do what it can and do type conversion internally. But it's a little bit tricky sometimes because some functionality expects an integer for you, from you. Okay, what else can we do? So when we have 100, this is an integer. If we have 100 divided by 10, this becomes a float number, right? Now, do you remember my name? My name is not defined because I restarted the kernel because I overwrote Python, so my name, right? So let's say my name, and I want to access, let's say, the third character, which is at index position 2. So far, so good? H, right? Count at 0, 0, 1, 2, so I get the H. But now I'm like, well, maybe 6 divided by 3. 6 divided by 3 is how much? 2, right? But it's not an integer anymore. So when I execute this now, I get this error. String indices must be integers, not float. That might be a confusing message, right? Because you're like, yeah, the numbers check out, but it's the type that is different here. But this is just one example where the internal type conversion that Python is doing sometimes is problematic. And so there are cases where you actually change a string and then convert and stuff, especially when you work with like a lot of data. So to prevent this, we already saw how to convert an integer into a string. We also convert a float into an integer, right? And we are back to H, okay? So yes, Python does a lot of things. We can iteratively update numbers, but data types may change. And then if you continue using this information for some other operations, you might run into trouble with your data types. So make sure that you not only follow the numbers, the values, but also keep an eye on the data types. Okay. Comparing values we did last time, right? Binary. We get binary results. Right? So smaller, larger, equal, we know equal. That is not 1 equal sign, but 2. And we always get true or false. Back now. Oh, this is interesting. We have A equal 1, b equal 2, right? 1 and 2, no problem, easy. 2 and false, we get equal. Now there's a difference here if you check very, very carefully. A equals 1, right? Equal, equal. It checks if the value of A is equal to the value on the right. We change the integer to a float number, 1.0. And it is still 2. Okay? So far, so good. Then I have another example. A is 1. So that is false. Let's see. So A equal 1. A is 1. Oh, this is 2. Here it's false. Can you see the difference? Once I check if it's a float, and once I check if it's an integer 1 value. So there are differences between checking the value and checking the content. If the content must be exactly the same, right? I check the value and the data type. If I'm just interested in the value, well, then I don't care if it's a float or an integer. Okay, and now when I execute this part here, there is a lot of information suddenly Python spits out, right? But these are syntax warnings. Meaning it's like, so what you do is a little bit dangerous, and I know that's dangerous, so let me tell you why. Right? So this is with illiterate. So do you mean equal again? Actually. So it still works, right? But Python is like, is this really what you want to do? Okay, so be a little bit careful here. The other thing is maybe I get this working. 3 divided 10 divided by 3. Yes. Okay, so how much is 10 divided by 3? 3 and 1/3, right? 1/3 does not end on 5. Is that true or not? It doesn't, right? It's like 3, 3, 3, 3, 3, 3, 3. If you round that, it rather rounds to 0 than to 5. That's weird. Let me see. I store this in C. C times 3. This is 10. 10 equal 10. Okay. So this worked. Let me see. Huh? Is that right? So when I have, no, that is 12, 13. How much is 3 1/3 times 3 plus 1? This one is, oh, so it must be 11, right? Let's see. No? What? 11? 14? How much is it? How much is C? How much is 4 times 3? 12, right? 12 times 3 is how much? No. 4 times 3 is how much? 12, right? What is 1/3 times 3? Is how much? 1, right? 12 plus 1 is how much? How much? 12 plus 1. Huh? Am I doing something wrong? I only had 1 coffee this morning. I probably do something wrong, right? What is 4 times 1/3 times 3 is how much? Are you talking to me? Did I do something wrong? You should get 13, right? Can you follow what I'm doing here? Okay, let's do it easy, right? So 9 divided by 3 is 3 plus 1, 10, right? 10 times, so now it's 4, right? 4 times 3 is how much? 12. Now I have 10 here. 4.3, 4 times 3 times 4 is how much? 4 times 3 times 3 should be 13, right? Shall I C times 3? It's 13, right? It's right there. It's not 13. It's 13.0000002. So yeah, this is rounding error sensitive. It's different. In some cases, you see I remove the +1 here, right? I get C is 3.333, right? And then I check if this one is equal, what is it, 10? There the rounding errors are not important, Python can handle, right? That's because I only have one operation. It's like, okay, Python is smart enough. But if I have 2, then you must be very careful with your integers. What is it like? What did I say? 13 here, right? Again, be careful what you do. If you want to convert, this is one way out. It's not a safe way out because this conversion cuts off all the digits after the decimal place, right? It's one way around. The better way is we actually would have a proper rounding function. We come into this in the numerical part. But lesson here is be careful with the equals. It really checks either the value or the content. For the content, data type and value must be identical, right? Must be really, really identical. Whereas for the equal comparison, right? If the value is equal, the content-wise is enough up to the rounding errors. So be careful with rounding errors. Keep in mind they can happen. Okay, what else? Boolean expressions or not and. So Boolean expression we said follows a Boolean format, so something is true or not. In an or statement, one of them must be true, right? Today I go to school. If it is a Monday or a Tuesday, right? So it's Monday or Tuesday, you go, right? If it's Wednesday, you don't. But it cannot be, well, both logic writers are possible. But you can say, I go to school if it is sunny or Tuesday. That means if the sun shines, you go to school, or Tuesday. So if it's raining on Tuesday, you still go. And if it's Sunday, if it's sunny on a Sunday, you also go. And is different. I go to school on a Monday, and if I feel well. So you must feel well. What did I say? Sunday? Monday? I go to school on a Monday and I feel well, right? So it must be Monday and it must feel well. If it's Monday, I feel sick, I stay at home. if it's Tuesday and I feel well, I stay at home. Not statement inverts everything, right? I stay not at home, not on a weekend. So not a weekend is a weekday, and stay not at home, right? I go out on Monday to Friday. So not is inverting the statement. Let's see. Play around a little bit, right? Not true is what? False, right? Not true or true is what? Well, it's true, right? Because or always gives you back if it is one true. So we could replace this with a not false as well. True. Let's see what else we can do. We can do true and false. So when you do an experiment and you measure the mass of an electron to be the value, right? And another one is taking the measurement of the mass of an electron to be 10 kg, right? Then you have 10 kg towards 31 point something, 1.6 times 10 to the power minus 31 kg or something like this. One of the values must be false, right? They can't be true both at the same time. Right? 2 plus 2 is 4, and 2 plus 2 is 5. One result is wrong. Right? So there must be something wrong. Okay, what else do we have? We have true or false. Okay, so this is only one option needed. We have false or false. It's always false. Okay. Right. So one shorthand notation for not is the, how do you call the symbol, by the way? Apostrophe, right? And equal. So when A equals 1, right? Then A is equal to 1, gives you 2. And the question is A not equal to 1, gives you false, because 1 has the value, A has the value of 1. If you want to change this to a true, you can ask any other value. Like, is A not equal to 2? Yes, because that's 1. Is A not equal to 20? Yes, because it's 1. What else? Keywords we got. We can combine logical expression through the binary keywords and comparative operations. That's all fine. Right. Task 6. Explain the following result. True is not equal false. But this is true because the opposite of false is true, and then true equals true, which is true. Okay, so now the lecture shall be 2 hours of me talking and 1 hour exercises, right? So when you go to Cyber University, you find a sheet, you find a notebook, practice. First one in 2024. You need to download this and bring to your Jupyter Notebook home folder. So you take it from the download folder and put it in whatever folder it is on your device. Okay? And then you open it and it looks like this. Open. There will be a couple of tasks, like normally I put like 10 to 50 inside, any number in between. And it gives you a text, define a function computing the square of a number. You know what's a square, you know what's a number, you know what's a function now, how to define a function. And then you try to type the answer here, right? So def my function, and you see how much of the coding examples, of the coding content you understood from the lecture, right? You try yourself. If you get stuck, you ask your friend for help. If you get both stuck, you ask the TA or me for help. I will go around and try to assist you. If you need help, you let me know. And this is the last hour of our lecture, right? So we have 2 hours of me doing something, and then you try your hands on some coding. So far, so good? Okay, if no questions, then we have a few minutes, well, until 12 o'clock to go through. Don't get, by the way, too upset if there are some things you don't understand yet. There are 40 things to do. Try what you can. It takes a little bit, goes a little bit ahead of what we are right now. Next week, we look at it again, right? We slowly build up, and at the end of, like, I think in 3 weeks or so, you should be able to run this task sheet on your own. Okay, but start and see what you can do already. I will